Welcome to our lesson on the Introduction to Polynomials. Our learning targets for this lesson are to be able to identify monomials and figure out what the degree is of any monomial. Then we also want to be able to find the degree and the leading coefficient of a polynomial. And lastly, in the end of this video, we will be working with adding and subtracting polynomials. So first off, what are monomials? And monomials can be numbers, they could be variables, they could be numbers and variables that are multiplied together, or they could be numbers and variables multiplied together as long as we have whole number exponents. So I have a whole bunch of terms here, and our goal is to see which of these are actually monomials. So they have to be either numbers or letters or variables, and they have to be multiplied. So this one right here on the left, this is not a monomial because it's subtracted. Okay, they're not multiplied. This one is a monomial. Okay, has a whole number exponent. This is a monomial. This one is not because our exponent is not a whole number, it's an integer. Can't have negative exponents. For that reason, this one is not a monomial, neither is this one. Okay, no variables in the denominator. This is a yes, and a yes. Okay, so as long as we have a whole number exponent and we have things that are multiplied together and we have numbers and variables, then it's a monomial. To find the degree of a monomial, all we're going to do is we're going to add the exponents of the variables. So this one would have degree 2. This one would have right here degree 2. We would add them together. This would be degree 3. Let's take a look at some more examples. In letter A, we do not add the degree of the constant term, but we only add the degree or the exponents on the variables. So A and B both have an exponent of 1, even though it's not written. And C has an exponent of 5. So if we add those three together, we get 7. So the degree of that monomial is 7. For letter B, we have an exponent of 1 for x, 3 for y, and 2 for z. So that gives us 6. And in letter C, we have a 1 for C, a 3 for B, and a 1 for A. So that gives us 5. Remember, we don't add the exponents for any constants or number terms. The degree of a polynomial, then, is just the degree of the highest degree monomial. So if we have several monomials added or subtracted to give us a polynomial, and we want to find the degree of the polynomial, whichever monomial has the highest degree is the degree of the polynomial. A leading coefficient is a coefficient or a number in front of the term that has the highest degree. And then standard form is just writing the polynomial where the terms are in decreasing order of degree, from greatest to least. So let's put some of that into practice so we can make sense of this. Our directions say to write each polynomial in standard form, and then we want to find the leading coefficient. So for this first problem, to put this thing in standard form, we need the one with the highest degree first. So 7x cubed comes first, and then the 5x squared would come after that. Remember to keep the sign that goes to the left. Then we would have negative x, and then we would have plus 8. So that is in standard form. Find the leading coefficient. So the leading coefficient, okay, whatever we have for leading coefficient, is the number in front of the term with the highest degree. So this polynomial would have degree 3. The leading coefficient would be 7. For letter B, to put these in order of highest degree first, our 2b to the 4th term would come first, minus 2b to the 4th. And then we have plus 3a squared b, that has degree 3, and then minus 6ab, and then plus 5. So the degree would be 4. The leading coefficient is the number in front of the term that has the highest degree, so that would be negative 2. For letter C, if we put that one in decreasing order, the highest degree term, or the highest degree monomial, is the negative 7x cubed y squared. Then comes the negative 2x squared y, that has degree 3. And then comes the 3xy, that has degree 2. Leading coefficient then is the number in front of the first term, which is negative 7. We have two different ways of classifying polynomials. First of all, we can classify them by the number of terms. We can also classify them by their degree. So first off, if we have only one term, we call that a monomial. Here are examples of monomials, okay? So the number x squared y cubed, or the expression, that's called a monomial because things are multiplied together. Just the number 3 by itself is also a monomial. It's a single term. A binomial has terms that are added or subtracted, and it contains two terms. Things like x squared minus 2 or xy minus 8. There are two different terms separated by addition or subtraction. A trinomial has 3 terms. Anything that's 4 or more terms is called a polynomial. When we classify by degree, I'll give you some examples and what they are called. Anything that has a degree of 0 is called a constant. For example, the number 5. Any single number is a constant and has degree 0. If it has degree 1, it's called a linear term. An example would be x plus 7. That would be linear. Its degree is 1. The highest exponent on the variable is 1. A degree 2 is called a quadratic. We've spent a lot of time talking about quadratics. And an example of a quadratic is x squared plus 1. Highest degree is 2. A cubic equation or a cubic polynomial has degree 3. And so there's an example of a cubic. So we could have a different number of terms. We could have 7 terms, we could have 3 terms, whatever it is for a cubic equation, as long as it has the highest exponent is 3. A quartic equation has degree 4, looks like that. A quintic has degree 5, and then anything that is more than 5, we just say it's an nth degree. If it was degree 6, we would say it was a 6th degree. If it had degree 10, we would say 10th degree. Okay, whatever it is, we would just use that number with a th. So how do we add polynomials together? Well, it says add the polynomials. We want to write the answer in standard form and then classify the answer by degree and the number of terms. We want to always remember we can only add and subtract terms that are alike. So let's go ahead and jump in here. So what terms do I have that are alike here? I have an a squared term here and an a squared here. And then I have a 6a and an a. And then I also have a constant term, a plus 5 and a minus 8. So those are my like terms. So when I add them together, the negative 2a to the 4th does not get added to anything. So he stays in the answer. He's going to go first. The next highest degree is the a squared term. And I have 3a squareds plus 1a squared is 4a squareds. And then my linear term, minus 6a plus a, is a minus 5a. And then my constants, 5 minus 8 is minus 3. So we would classify this by degree and number of terms. So this would be a 4th degree or a quartic polynomial, right? And how many terms does it have? It has 4 terms. So we would call that, if it has 4 terms, we would just call it a polynomial. So it's a quartic polynomial. And then letter B, this time we're adding 3 terms together. So let's see what terms are alike. We have a 3a here, a 7a here. Then we have a minus 2b and a minus 2b. And lastly, we have a plus 5c, a minus 3c, and a plus 7c. So let's get the like terms together. 3a's plus 7a's gives us 10a's. Minus 2b and minus 2b gives us minus 4b. Plus 5c minus 3c is plus 2c, and plus 7 more is plus 9c. Okay, so the degree of this one is degree 1, right? So this would be a linear, is how we would classify that by degree. And the number of terms are 3, so it's a linear trinomial. And there you have it. Subtracting is very similar to adding, except we're subtracting, obviously. So same kind of direction. Subtract them, write the answer in standard form, and then we're going to classify it by degree and number of terms. So let's look at what terms are alike before we get started. So we have a 4z squared and a 2z squared, a minus 5z and a plus 7z, and then our constant term, a plus 3 and a plus 3. So to start off with, we have 4z squared minus 2z squared gives us a positive 2z squared. A minus 5 minus 7 is a minus 12z, so don't forget to distribute that negative. It changes all the signs. And then we have 3 minus 3, which is 0. So that term just drops out. So now let's classify this thing. Our degree is 2, so we would call it a quadratic. And it has 2 terms, so we're going to call it a binomial. All right, letter B. Our like terms are, here's a cubic term, and here's a cubic term. Then let's look for any squares. We have an m squared and an m squared. Those are alike, right? And let's see, we have some linear terms. We'll put those in blue. And then lastly, we have our constant terms, which we will underline in black. So let's go ahead and get our like terms together, and using the highest degree first. Minus 7m cubes minus 10 is minus 17m cubes. We have a 1m squared minus a minus m squared. So this one's going to be a plus m squared, so that gives us plus 2m squareds. A minus m is a minus 2m, and a minus 3 minus 2 is a minus 5. So make sure you're changing all of your signs. You have to distribute that negative all the way through. So it would be a minus here, a minus, and a plus. Classifying this is a third degree. So third degree we call cubic. And it has 4 terms, so we're going to call it a polynomial. Our last line here says the perimeter of an isosceles triangle is 8m minus 11n. The length of each of the 2 congruent sides is 3m minus 8n. Find a polynomial for the length of the third side. So first of all, the 2 sides that are congruent, meaning the same length, are 3m minus 8n. We want to find an expression for this third side. So we know perimeter is the distance around. So we know the perimeter is the length of the 2 sides, 3m minus 8n, right? And actually, rather than multiplying that, let me go back here. I'm not going to multiply that. Instead of doing that, I'm going to go ahead and just add those together. We've got that one plus another 3m minus 8n. And we know that that's going to equal our perimeter that was given in the beginning, 8m minus 11n. So what we want to do is combine our like terms. So let's go ahead and look at our like terms here. This term and this term are alike. And then we have this term and this term are alike. So let's get those together first on the left side. So when we do that, we get 3m plus 3m is 6m. Minus 8n is minus 16n. And that's equal to 8m minus 11n. So now we need to get the rest of our stuff together. And getting our like terms together, we want to get our m's together. So if our perimeter is 8m minus 11n, how much more do we need to add to our 6m to get 8m, right? So we haven't added our third side. So we're going to add a third side, so we don't know how many m's. So something's going to be added here. And we want this m term to equal this m term. Well, we need 2 more m's, right? So we need 2m. And then we have a minus 16. We want it to be a minus 11. So we're going to have to add 5 n's to that. In order to get the left side equal to the right side, our third side would have to be 2m plus 5n. That's it for this video. See you next time.